Okay, so you're gonna be given a problem. In this example, it says that Benjamin's Banana Split Shack ice cream costs $3 plus 50 cents per topping. So you have to come up with a table of values where we're relating what? What are the two things that are being related? Yes, number of toppings and the cost of the ice cream. Please make sure you put the values correctly in the table. These are our x values and this is our y value because the number of toppings is independent. So it has to be x, right? The cost depends on how many toppings you get. So let's fill in the table. If I get 0 toppings, let's go up to 1, 2, 3. It says up to 4 toppings for question A. If I don't get any toppings, is my ice cream free? Is it $0? I still have to pay $3 for the ice cream. So just by that right there, is this going to be direct or partial? Let's skip to question C. Raise your hand if you think this relationship is going to be directly related. It's going to start at the origin. Who thinks it's going to be partial? Excellent. That's for C. We know it's going to be partial because where is it going to start? 0, 0, 3. The y-intercept is going to be 3. Every time we get a topping, how much extra is it going to cost? So if I get 1 topping, I have to pay $3.50. If I get 2 toppings, how much do I have to pay? I have to pay $4. Every time I add a topping, we're going up by 50 cents. And actually, I shouldn't, yeah. Okay, so for 3 toppings, how much does it cost? $4.50, and then for 4 toppings, it's going to cost $5. So if I were to ask you, this is on your test as well, calculate the first differences, and I already did it, so I kind of just gave you the answer. Do you remember how to calculate the first differences? Let me erase this. We are subtracting, this is on your test tomorrow. We take $3.50 minus $3 and I get 50 cents. Then I have to do $4, take away $3.50. I get 50 cents. You're finding out the difference between the y values. Okay? $4.50 minus $4 is 50 cents. $5 minus $4.50 is 50 cents. Remember we did this? Are the first differences all the same? What does that tell you about this relationship? The first difference are constant. Very good word. They're increasing by the same amount every single time. So what does that tell you about the relationship? Is it going to be linear or nonlinear? Linear. Again, all of this stuff is on your test. You need to know words like constant, linear, first differences, which is the change in the y values. These are our y values. We're figuring out how it changes every time. It goes up, it increases by 50 cents. So when you graph this, do you think it's going to be positive or negative line? It's increasing. Every time you add a topping, do you have to pay more or less? So is the graph going to increase or decrease? Increase. Okay, so we can add that to this. It's going to be increasing. It's going to be positive. So if I ask you to come up with an equation that shows me how would I calculate the cost of ice cream? Well, what is the cost? $3. It's $3? That's it? No. Then what? Plus 50 cents. That's it? Ah, excellent. And you see how that equation, this was our y-intercept, and this is our rate of change, or the slope. So now I want you to calculate if this person wanted 7 toppings. You can use the equation now. Do it right now. If they want 7 toppings, they have to pay 50 cents per topping, plus they have to pay $3 for the ice cream. So calculate it right now. What is the cost of ice cream with 7 toppings?